Good afternoon, everybody, and welcome to the SMARTrenew Pilot Showcase. My name is Nick Timmins from the Weiser Lab and Letterkenny Institute of Technology. We're the lead partner of the SMARTrenew project, and today we're bringing you the showcase of all the pilots that are partners across the various countries in the Northern Periphery and Arctic Interreg region. We're going to present all the pilots today that are in developed and have been completed. So we have a pretty tight schedule. We've got 7 speakers. So I'm just going to, first of all, give some background and talk a little bit about the SMARTrenew project. So I'll talk about that for a few minutes, and then I'll introduce a little short explainer video, and then we'll move straight into our first speaker. So I'm going to share my screen now and presentation up here. So a little background on the SMARTrenew project. It's a Northern and Periphery and Arctic region, Interreg region project. Its value is 1.65 million. It started 3 years ago in October 2018, and it ends on March 2022. So it ends in the next few months, but it will continue as part of the NPA heater cluster project until June 2022. So it will be functional, will be disseminating more results over that period. So we have the countries involved are Ireland, Northern Ireland, Finland, Norway, Iceland, and the Faroes. And this is a photograph of us just before lockdown, when we had our last face-to-face meeting up in Iceland. And after that, like everybody else, we went into the virtual world. But we'll hoping that we'll have a final conference in Finland, and SANNA from Finland will talk a little bit about that later on. So basically, the challenges that SMARTrenew was tackling are those experienced by the Northern Periphery and Arctic area, and you can see that area highlighted there in the little map of the region. So this is an area characterized by colder climates, low population densities, still dependencies on fossil fuel for heat and energy, and with in general terms, a poor uptake of smart renewable technology. So this project was looking to address some of that, and you can see I've highlighted in red the high cost of fossil fuel leading to fuel poverty and insecurity, and that is before the recent massive hike in gas and home heating oil, and of course petrol and diesel. So our project was looking to address that, looking to come up with some ideas and pilots and share knowledge and technology across the region. We focused on, first of all, building up a smart rural communities and building up a directory of services and solutions. And then in red is really what we're going to look at today. We developed and designed some pilots, and that's what this seminar is about today, about introducing those pilots and each of our partners describing what they've done, what their aims were, and what the outputs they hope to have from that. Overall, the results that we have to achieve there in bold, you'll see 6 pilots implemented across the network. We actually have 7. A minimum of 18 housing and public buildings retrofitted with smart renewable energy and storage solutions. 1 smart storage device and 1 renewable service. And you'll see that all of the pilots have implemented a storage solution and in general terms a mix of renewable energies, and that really is the way forward. We cannot rely on one source of renewable energy. We need to have a mix of renewable energies, and we need to not waste our renewable energy. So methods of storage will be discussed today as well. So this is the agenda, and these are our speakers. I'll not go through them all. I'll introduce them as we go along, and there we all are, all the speakers, not in that quite in that order. And we'll just follow up here now with a video, 3-minute video, just explaining SMARTrenew.
What is SMARTrenew? SMARTrenew is a €1.6 million three-year project. It is co-funded by the Northern Periphery and Arctic Programme. The aim of SMARTrenew is to increase the awareness and implementation of smarter renewable energy sources and energy storage solutions across the Northern Periphery and Arctic area. SMARTrenew Partner Map. Project SMARTrenew combines partners based across 6 countries of the NPA region who share common challenges, opportunities and goals. SMARTrenew is led by the Letterkenny Institute of Technology based in Ireland. Donegal County Council is also based in Ireland. Derry City and Strabane District Council is based in Northern Ireland. OULU University of Applied Sciences is based in Finland. Iceland's Energy Agency is also a SMARTrenew partner, as is the SINTEF Private Research Institute based in Norway, and the Environment Agency of the Faroe Islands. Shared partner challenges. Low population densities. These regions have 6 inhabitants per kilometre, compared to the European Union average of 117 inhabitants per kilometre. Cold climate. These regions experience cold climates. This leads to fuel poverty and fuel insecurity. Low accessibility and connectivity. The remote settlements are far from urban transport hubs, leading to higher fuel costs. Renewable energy often produces more than what is required by local populations. The energy storage is underdeveloped, and projections predict that temperatures will rise higher and earlier in the Arctic region than in the rest of the world. Joint partner opportunities. These areas are rich in natural resources. Knowledge can be transferred between the 6 countries. There are varying levels of energy maturity, and there's the potential to develop smart renewable energy and heat storage solutions. Common partner goals. These include reducing energy poverty, finding ways to improve the renewable energy mix, reducing reliance on fossil fuels, finding ways to implement renewable energy, EU green targets, and reducing carbon footprints. SMARTrenew output and results. To showcase smarter energy rural communities, 6 rural communities will be set up with smart energy technologies and resources as showcases to demonstrate how a smart energy community could function. To retrofit existing buildings with smart renewable technology, 18 houses and public buildings will be retrofitted with smart renewable energy and storage solutions. To develop a smart energy action plan. This is an action plan to incorporate a range of smart renewable technologies and heat storage solutions, and to tackle energy poverty in rural communities. For more information, visit the SMARTrenew website or follow us on Facebook, Twitter and LinkedIn. SMARTrenew is co-funded by the Northern Periphery and Arctic Programme and partners.
Okay, thank you. Hopefully that went across okay and you heard it. We had some sound issues earlier on when we were running it. So just before we move on, if you have any questions today, if you could put them into the Q&A box, and then we hope, if we can keep on time, we hope to have a little bit of a Q&A session at the end. If we are ahead of time, we might just take a question or two in between speakers. But I will introduce now our first speaker. Now, unfortunately, Ziggy FRIÐLEIFSSON from the Energy Agency in Ireland was unable at the last minute to attend live, so we have a video of him. But there should be his colleagues in the background if you do have questions for him. So we'll start with Ziggy first of all. Thanks, Maria.
Yes, I want to talk about our pilot project in the SMARTrenew program, and that's about Grimsey. Here we have a quite cold picture of Iceland, and as you probably know, Iceland is the renewable island where almost all the electricity and heat is produced with clean renewable energy. both hydro and geothermal. The reason why it's not totally 100% is simple, and that is here where we still use fossil fuels in this tiny island in the north. The island has about 50 inhabitants, and it takes about 4 hours in a ferry with a seasickness guarantee. We know too much about that with our trips to the island regarding the project. The diesel used for heating is about 200,000 liters per year, and also the diesel used for the electricity and the diesel generators is about 250,000 liters. So we have some liters to reduce, and with SMARTrenew project, we are finally starting to phase out the last oil user in Iceland. Here you can see how the system works in the island. On the right, you have the diesel generator with the dirty smoke there and the terrible noise. And also, this is a typical house in household in Grimsey with oil container for the oil heating. The SMARTrenew plan is to start the transition to renewables and increase the energy efficiency. We are switching to LED lights and we are putting up 2 6-kilowatt wind turbines and 12-kilowatt solar PV unit. So there will be 12 kilowatts in wind and 12 kilowatts in solar. That will be a kind of competition between those two green solutions. I am betting my money on the wind because I've been there and there's plenty of wind in Grimsey. But we hope also the solar will come strong in, and the thing is that the tourist industry is growing in Grimsey, and they usually come in June and July when the sun is almost shining 24 hours. This is the island, and you can see here that on this spot, this is the old diesel generator, and the plan is to put the solar panels around here. And after some quite a thought and trying to figure out a good place for the wind, we finally decided to put them here up on the highest point on the islands, where we already have some kind of radio masts, and we have almost a road, and there is a grid connection there. So this should be the perfect place for the wind turbines. We have been there a couple of times with the locals, telling about the project and getting them involved. And the milestones so far is that this project has been very hard, and maybe the biggest milestone is when we managed to change the regulation to fit the renewable energy into the very specific agreements that is between the state and the energy producer on the island. So Iceland is not familiar with solar and wind, so it was we had to actually change the law or the regulation to be able to fit this installation into the grid. So that was a huge milestone. And also it took time to introduce the plans to the residents. We have to take to consider the birds and etc. And then we had quite heavy work in just getting very complicated permits for the construction. And again, that's also because there's no history here in Iceland for projects like this, because we always have this hydropower and geothermal that is plenty of. We have already finished the LED installations, both in all the households. We gave all the residents a pack of LED light bulbs, but also the lights poles by the municipality. They changed that, and that is actually quite a lot. We estimate that we can save around 8,000 liters of oil just with the LED installations. We have bought all the equipment, and we had to buy equipment that would be extremely weather tolerant, because the weather can be extremely harsh in Grimsey. So we need to have equipment that can tolerate both heavy and unstable wind and cold and etc. And then we have also made the agreement, the very important agreement with the energy company to actually run and serve the units. But the main thing about the SMARTrenew program is that this will be we will pave the path for like the final solutions where we can hopefully take most of the oil out of the system. And the plan is to, if everything goes well and the project will be successful, that we are very hopefully seeing that nothing bad will happen, then we will. The plan is to add at least 4 more turbines or even more to the system. That actually will make the wind turbines the biggest wind turbine park in Iceland. We will offer the residents solar panels on their own properties based on the experience we will have from our PV unit. And the plan is then to install battery to stabilize the grid and open up for a fully renewable system. We will even blend the diesel, and hopefully the diesel use will be very limited, but the tiny drops that will be left can come from locally produced biodiesel. So that will help us make the final step to 100% renewable system. We also will offer the all households a pellet burner and heat pumps, so they can take out the oil heating. And that is a huge milestone, because then we can finally quit the oil subsidies that we sadly still have for these people. And we will have then a system with electric heating from renewables mainly, in combination with a heat pump. And here you can see one of the houses in Grimsey, and you can also see the church there. But sadly, on 1 hour trip, the church burned down totally. I actually see it as a sign that we should stop burning things in Grimsey. And this is the only thing that I managed to get out of the ruins. And I think it says in Old Icelandic, it will all be fine in the end. Thank you.
Nick, you're on mute, so you are.
Sorry, everybody. Yeah, the usual problem. I was on mute there. Thanks to Ziggy for a slightly controversial end there to the talk. Very interesting application up there in Grimsey Island, the last part of Iceland, which is dependent on oil. We're going to move on quickly now to SANNA from OULU University of Applied Sciences in Finland, and Sanna is going to talk about her heat storage combined with district heating to reduce oil use in Kuusamo, which I hope I pronounced properly, but if I haven't, Sanna will correct me. And I'll hand it over to you now, Sanna. Thank you.
Hi everyone, thanks Nick for the for presenting me, and thanks to Iceland for the very interesting presentation. Also, please let me know if you can't hear me or if there's some problem with my presentation. Now you should see my screen, and now you should see my presentation. Yeah, just like Nick said, I'm from Oulu University of Applied Sciences, and I have 3 topics which I'm going to talk about. And the first one is the smart heat storage pilot. And then I'm going to introduce our brand new hydrogen working group, and then a few words about the SMARTrenew final conference. First, a little recap about where we are in the world. So here you can see Oulu. It's sort of in the middle ground there on the waist of Lady Finland, but it's considered to be in the northern Finland, and it gets quite cold here in winter times. Arctic Circle is somewhere here, I believe, a bit higher, a bit further to the north, but it's Lapland there already. And my organization offers education for over 9,000 students in multiple fields, including business and engineering, health and social care, and information and communication technologies, media and performing arts, and natural resources. We share a campus with the University of Oulu, and it makes us one of the biggest campuses in Europe. Someone even claimed that it's the biggest in Europe. And we have a very we do very close cooperation with Northern Enterprises, and want to take part in supporting and developing the Northern vitality and research and development and innovation work is also important thing for us here in Oulu. About our pilot, it's a SMARTrenew pilot by us, done in collaboration with Energy and Water Cooperative in Kuusamo. It was very close, Nick. It was very good. Firstly, to let you know where Kuusamo is, it's to east and a bit further north from Oulu, near our eastern border. It's an over 15,000 resident city in northern Ostrobothnia. And if it gets cold here in Oulu, it gets even colder in Kuusamo. It's easily minus 30 degrees or colder in wintertime there. And the Energy and Water Cooperative in Kuusamo, or EVO, as it can be called for short, is a cooperative that is responsible for district heating, water treatment, and clean water distribution in Kuusamo area. And they deliver district heating to to nearly 1,500 properties. They've been established in 1950 and treat 3,000 cubic meters of sewage per day and a little under that of clean water. And it's owned by over 4,000 different owners. Now, the primary challenge we wanted to meet with the pilot is the use of fossil fuels in rural areas to cover spikes in energy demand. As I said, it can get quite cold in there, and sometimes the main heating plants can't quite meet up with the risen energy consumption, and they need their auxiliary heating plants then. And the challenge is that they have in Kuusamo this oil burning auxiliary power, but they want to make the district heating greener. It's quite green already, but you can always make it a bit greener, and that's what they want to do. They are quite ambitious and very invested in building a greener future, and also increasing the profitability of CHP, combined heat and power plants. It's never a bad thing. So if you can save some money or make some more money in the while making world a greener place, it's always a good thing. Now, our solution, the smart heat storage, eliminates the need for oil burning auxiliaries, reduces carbon emissions, and is cost effective. So it's a win-win-win situation. The underlying magic here, technology, it's a 500 to 600 cubic meter water tank where the heat from the CHP is stored. And it can be then used when the temperatures go very low and additional energy is needed. It's a matured existing technology, so it's relatively fast and easy to implement. There are experiences and know-how how to use that kind of technology in Finland. The environmental gain comes from the reduced oil consumption, and financial gain comes from the savings from the fuel costs, as well as from added income from increased electricity sales, as the heat storage can be used as a customer for electricity production. So the CHP plant can generate electricity, and they can store the excess heat to the heat storage. The innovative part here is what we took up on calling a smart component. And it's a calculator to help optimize the use of the heat storage based on past weather data and energy consumption data and weather forecasts. It calculates the need for heat storage capacity in the upcoming hours. And hopefully in a longer run, it could be turned into a software, so the use of the heat storage can be fully automated. The heat storage utilization cuts down the carbon footprint of heating and improves energy security in the northern rural area. The smart component helps to optimize the use for best results. There have unfortunately been some obstacles in finding equipment supplier and also with the lot for the heating storage, which has led to some delays. But now we are waiting for last permissions about the lot where the heat storage is to be built, and construction will start in early 2022. And while SMARTrenew project will probably end before we can get results from integrating the heat storage to the district heating network. We will continue collaboration with EVO and collect and analyze the data from the heat storage use. And thankfully, there is the heater cluster project through which we can still disseminate the outcomes of this pilot. Then our SMARTrenew Hydrogen Working Group that we set up here in Oulu. The transition to hydrogen economy brings forth new competence and education needs, and we thought that we need to somehow respond to that challenge. Now, we don't know what the hydrogen economy will look like in northern Finland, what kind of know-how and skills are needed, and how can our education best respond to the future needs. So to answer to these questions, we set up this hydrogen working group to find out enterprise needs and study business model possibilities here in North, so that we can understand what future competent needs there will be, and also to start integrating and increasing hydrogen education. And to do that, we need to increase hydrogen know-how and competence among staff also. Here you can see us in our, it's not the very first, but it's from one of our first meetings. And when you have coffee and cinnamon buns, there is no challenge too big. And hydrogen will play a significant role in transition to zero carbon energy. So action needs to be taken now to ensure northern know-how and competence to match the need in the future. And that's what we want to tackle. Last but not least, the SMARTrenew final conference in March 2022. I am delighted to welcome you all to Oulu, Finland, on 22nd to 24th of March. And we'll have talks and presentations regarding SMARTrenew themes, and talks about next steps on the road to zero carbon energy. There will be networking possibilities and also funding information about ongoing and upcoming funding instruments and possibilities. And of course, cinnamon buns all around. That's all from me. For more information, please visit our SMARTrenew website. Thank you, and I hope you'll have a great day.
Thank you, Sanna. Thanks very much. I'm going to move straight on here to Donegal County Council and PEADAR ESPEY, the facilities manager, and his pilot was looking at one of their public buildings, library, and retrofitting that with renewable energy and removing their reliance on oil. So thank you, PEADAR. You can take it away there.
Thanks, Nick, and also thanks to Siggy, and also thanks to Sanna for your presentations also. So yes, as Nick mentioned, I'm with Donegal County Council, Executive Engineer, and I'm Donegal County Council's partner representation on the SMARTrenew project. So just to give you folks an overview of Donegal. So County Donegal is based in the northwest of Ireland. Our borders are with Northern Ireland, approximately 140 kilometres. And then our remaining border is with the rest of Ireland, which is only 9 kilometres. Our population is based on the 2016 census. We have a population of 159,000 approximately, and that would have been an increase in 29,000 over the last 20 years. So our pilot location is in Milford, and as you can see from the map on screen, Milford is in the northern section of our county. So the pilot project that Donegal County Council took on for the SMARTrenew was at our Milford Public Service Centre and Community Library. The works commenced back in August of last year and were completed in November. So the reason this building was identified for a pilot project in particular was that it was in my idea, from looking at all our other public buildings, it was the most suitable in terms of a pilot and in terms of getting the best information to proceed to future projects in the next decade. So a few bits of knowledge about the building. The building is approximately 18 years old. The floor area of this building is 1,900 meters squared. And space heating to the building was provided by 2 number oil-fired boilers. And these were also 18 years old, requiring a lot of servicing and were due their end of life. Also, the building was ideal in terms of its fabric, and very little curtain wall glazing. We have a small bit of curtain wall and glazing at the entrances to the front of the building and to the back. And then the rest of the building was fairly modular in terms of the glazing. And the glazing was also of a very high quality, following a few inspections of the glazing, the seals and hinges and the operations. It was felt that the glazing would not have to be touched. So in the round, it was the perfect building to identify in terms of our pilot project for SMARTrenew. So what the project included in terms of renewable mix and smart storage was the installation of 3 42.6 kilowatt air source heat pumps, a 6 kilowatt solar PV array, which was 20 PV panels, and then fabric upgrades with pumped cavity insulation with platinum eco beads. So then the benefits of this pilot project for us in Donegal County Council was going to be the removal of the dependency on the heating oil, and with that the carbon removal, providing a smart renewable energy mix, providing smart heating and electric controls, and then the introduction of renewable energy technologies, and the learning and experience that will be gained in this process as part of the pilot project that we could then take on to further projects throughout the next decade for Donegal County Council. So this is just an overview of, before the project commenced, an overview of the estimated annual savings for the SMARTrenew project at the Milford Public Service Centre. So we had there our air source heat pumps, annual estimated savings of 184,263 kilowatts, cost savings of 8,680, and most importantly, carbon savings of 34.2 tonnes. The next element was your solar PV array with kilowatt savings through generation of 4,901, cost savings of 882, and carbon savings of 1.7 tonne. With the fabric upgrades, we have kilowatt savings of 11,399, cost savings of 969, and the carbon savings of 2.9 tonne. But in addition to those estimated annual savings, more recently here in Ireland, we have in the last few weeks, our government has announced and released their Climate Action Plan 2021. And within that plan, the government has confirmed its position in terms of the carbon taxation. So just alone, looking at those figures above, alone with taxation coming in now next year here in Ireland, we have a figure of about €33.50 a tonne for next year, 2022, and that's going to rise by 2030 to €100 a tonne. So just on next year's figures alone, This project already will save our organisation approximately €1,300. And if you apply that to the €100 a tonne carbon taxation in 2030, we're going to be saving about €4,000 come 2030 just on this project already through its implementation. So a few of the pictures. So on the bottom left there is the contract award. That's myself, and we have to the left there is the main contractor. It was a contractor here in County Donegal, a mechanical and electrical contractor with experience in this specific type of work. The middle picture there was a great day. That was the removal of the oil tank. The contractor brought in a heavy haulage company with a 35-meter reach. The proximity was difficult, but it was a great day to see that oil tank removed and moving now to the renewable source. On the right there is the PV installation, and that's the 20 panels. So it's a standing seam roofing system. And I was very keen not to have any of the PV penetrate down through the fabric. So the vertical seam upstands, the PV installer had clamps that could go on to the vertical upright of the seam without actual penetration down through the fabric. So I was delighted with that, to have the panels now on the south facing of the building without any actual penetration down in through the roofing membrane. And in addition to that, the building is alongside the river, which is at the lower level within the town, and the remainder of the town is on elevated sections. So a lot of the town gets to see the PV panels up on the roof of the building from their homes. That picture to the left, that's the top left, that's the pump controls, and all the controls throughout this energy upgrades are tied into our existing BMS system on the building with improvements and upgrades as part of the contract. So that's the pumps coming in from the intake from the three 42.6 kilowatt heat pumps. And we were very lucky that we were able to get all the controls, the likes of your and all the equipment into the existing boiler house. So we were able to fit everything within the existing boiler house. We have the likes of our buffer tank, our pressure vessel, our heat exchangers, and all the pumps, the main control panels. They're all inside within the existing boiler house. And then that picture there to the top right, that's the 3 air source heat pumps in situ. And again, from the picture on the previous slide, that's exactly where the oil tank was situated. So for environmental reasons, the oil tank was contained within a bund, and that's now where the air source heat pumps are, inside in that bund. We created an opening to get in to access the bund, and we also created a surface water gully within underneath the air source heat pumps for the condensated water to filter down through the clean stone into the surface water gully and out into the surface water network. And the bottom middle picture there is the fabric upgrade works, where the subcontractor, again a local company in County Donegal here, we're carrying out the cavity bead pump installation. So as part of the project, we were keen to have data, so to develop our future office retrofits and our public building retrofits. So that image there on your left-hand side is the actual image directly from our apps for the photovoltaic generation. So that's live generation information. It's available on phones, tablets, and on the PC within the building itself. It's given us great information. They're available throughout the year, 24/7. Okay. And then likewise, the image on the right is our data from the heat pumps. I was very keen to have CT meters installed on each individual supply to each individual heat pump. to get a firm knowledge of the consumption throughout obviously this current period and the years ahead. I didn't want to just rely on just the main electrical bill to the building, so I added this into the contract to give us clear data and to use that data in the years ahead for the tweaking, the monitoring and verification processes and with regards to the consumption of the heat pumps, and to use their information in future projects. So this is just giving you an overview of the first graph above is an overview of the photovoltaic generation since install. So the generation went live back in mid-September of last year, and then that you'll see there right up until October of this year, the generation. The one key factor here is, and it's great, the estimates you would have seen on the previous slide have been matched and have actually been improved on. So we had a couple of periods of heat wave here in Ireland and up in Donegal here during the summer months. So we got great generation. So it's great to see our estimates being achieved with regards to the PV generation. And on the bottom is our the consumption, the kilowatt consumption from our heat pumps. So going from January to September here, you can see the consumption, obviously the higher consumption with the colder months back in January and February, and slowly dropping off from March right through to September. I mentioned the monitoring and verification and the adjustments, and the previous slide showing the live data and consumption from the CT meters on the heat pumps. Without that data, already we've realized where we have consumption there that this time next year we will not have consumption. The pumps themselves probably realistically could have been turned off in full back in late April, early May. So that graph slide from probably August, September, this time next year for that building, you'll see that slide probably from mid-May right across June, July, August. So that information alone through the monitoring verification was great to have, and we've identified a bit of a flaw we had this year in terms of our operations, but that will be addressed now for next year.
1 minute there, Peadar.
Yes.
Sorry, no, just
right.
to wrap it up.
No, perfect.
Just try to keep the time going here.
No, I'm okay. Next slide, is it more or less? So in terms of the pilot project, the learning, so look, that was a live office retrofits that hasn't been completed yet within our organization. So those logistics and challenges surrounding that in terms of the staff and public interface during the works, health and safety, coordination of power shutdowns, the coordination of the heating shutdowns. Then we also now have a handle on our capital costs, so we can apply these costs now to our business cases for future retrofit action plans. Then we have our operation costs. We know our costs now from our live data, how we're going to monitor that, we're verifying that, and as I mentioned, the adjusting that. Then the image below, so already from the pilot project in Milford PSC, we are already implementing more or less the exact same project at Letterkenny Public Service Centre. So we've now embarked this year already replicating the SMARTrenew Milford project in our next public service centre in our largest town here in County Donegal. As you can see there, that's an image just from 2 weeks ago, where we have, due to the size and scale of that building, we have 5 42.6 kilowatt air source heat pumps, also PV panels and cavity fabric insulation. And in the next 4 or 5 years, the intention is to plan to roll out the replacement of the glazing on an annual basis. So I'd just like to say thank you to everyone for your time, and I'll hand it back to you, Nick.
Thank you very much, Peadar. Another very interesting talk. Great to see that the pilot has been rolled out into policy in the council and further council buildings. I see a few questions on the chat. I'm going to keep those towards the end, just to to make sure that I want to keep things moving so we have time for the questions. I'd like to introduce now Bjarke Thompson from the Faroe Islands. He's the energy manager up there in the Environment Agency. And PEADAR has another interesting pilot. It's going to talk about borehole thermal energy storage and water storage in their pilot up there in Faroe Islands. Thanks, Bjarke. You can go ahead.
Well, I have some difficulties here to share the screen.
I think that's we can see that now.
You see my screen now?
Yeah, we can see it now, Bjarke.
Okay, here we start. Yeah. Well, this is Bjarke Thompson saying hello from the Faroe Islands. I work for the Energy Agency, or in Faroese, Umhverfisstofan. This is a governmental body, and we are one of the partners in the SMARTrenew, the NBA project. I will give you a short introduction about the energy situation here in the islands, and then I will give you an overview of the related SMARTrenew activities, which they focus on the energy system here in the office building of our own. So for those that are not familiar with Faroe Islands, here we are, 18 enchanted islands in the middle of the Northeast Atlantic, north of Scotland. On our own, only inhabited by 53,000 people. Here we see a pie chart of the energy use in the islands last year. It summed up to 3,820 gigawatt hours, and 92% of the energy comes from imported oil. Only 4% is renewables, such as hydro and wind energy. We see in the right portion of the pie that the 42% is maritime activities. And at sea, we don't have that much alternatives to oil. But on the left side of the pie, we see power generation, oil burners for heating and industry, and vehicle as a land transport. And all these, we do have alternatives. We can switch over to electricity, and we can produce electricity from renewables. And in our islands, the solution is wind energy. We do have among the world's best situations for wind energy. Our annual wind speed is over 10 meters per second. So we produce a lot of wind compared to other wind turbines on the mainland in Europe, for example. But to go from dispatchable oil as an energy producer to intermittent wind, that poses some challenges. And I will explain these challenges in the next couple of figures. Here we see the electric power production in December 2018. And we can see that the demand is met by oil, the red one, the hydro, the blue, and the wind in green. So if we remove the oil, that's our wish, then we can see that it's difficult to meet the demand. And even if we install a lot of wind energy, there will be periods where we don't meet demand. And actually, we are rapidly building the wind now. Next summer, there will be two large, or in our perspective, very large wind farms coming online. So the wind energy in the islands will be more than tripled next summer. But as you see, even if we build that much wind, we have periods with lack of energy. But on the contrary, we do have a lot of excess wind in periods. And of course, the solution for this is energy storage, where we can store excess wind and use it where we have no wind. And we all know pump hydro, I suppose, where we can use excess wind to pump water uphill, and then we can use this water later on where there's lack of energy. But there, and of course we are doing we have opportunities. We have water reservoirs in different heights, so we have opportunities to build this, and we are planning this as well. But there are other possibilities to store energy, and one very efficient energy storage is a water tank. If you heat water, that's an efficient energy storage. If we compare potential energy, such as water up in the hill, with the thermal energy or heat energy, if you take 1,000 kilo of water and we pump it 400 meters up the hill, that compares to 1 kilowatt hour of energy. But if you take the same 1,000 kilo of water and you just heat it just 1 degree, it's the same amount of energy. So it's very efficient to store energy as hot water. And that is interesting when we speak about space heating, and especially maybe together with a heat pump. Peter talked about air source heat pumps. In our case, it's ground source heat pumps. We do have boreholes in the ground, and we use a little of electricity to extract heat from the borehole to heat a water tank of water. That is the storage, and the water tank can supply both tap water, radiator heat, and floor heating. And one interesting aspect of the heat pump is the energy, how efficient it is. In this case, with a coefficient of performance, the COP, if it's 4, then we use only 1 kilowatt of electric power to extract 3 kilowatt from the ground and produce 4 kilowatt for heating for the house. So it's a very efficient system, and it also has water tank as storage inside the system. So now we're going to talk about our own office building. This is the building where we have our office, around 2,000 square meters office space. And as a proponent for renewable energy, we of course don't want to use oil. Until recently, this building was heated by oil, using oil furnace. But now we decided to go for heat pumps and get rid of the oil. So early this year, we removed the oil burners, and here we can see the tank. In January this year, it was removed from our ground, and we started to install heat pumps. Here we can see the drilling equipment. The system was designed with 4 boreholes around 300 meters, but we decided to drill one of the holes down to 400 meters to have opportunities to learn more about the underground and also do experiments with this. So this is one of the holes that's drilled, and here we can see the bore equipment in the distance, and we also see the compressor that drives things. So this is a major undertaking of work to do outside the hole. And here we can see the pipe that is going down to the hole as well, in plastic pipes. Here on the left bottom, we can see a steel pipe. That is the top of one of the boreholes, and 2 plastic pipes are sticking up there. And on the right side, we can see people doing the connection work, using plastic tubes to connect the boreholes into the house. And major work outside, but also inside, a major work. Here on the left side, we can see all the pipes coming in through the wall from the outside into the building. And on the left side, we see the hot water tank, the buffer tank that can store the hot water produced by the heat pump. And then it's delivered to radiators and other need of heat energy. But as I mentioned, that we have drilled a 400-meter hole, and the purpose for that was to try to store energy down into a hole, and in addition to a tank with the hole. So our intention is to use excess heat, maybe from solar panels, and store that down into the borehole 400 meter deep, and see if we can extract that maybe later on. Maybe in summer we can store the excess heat, and then we can use it during the winter as heat for the heat pump. We have teamed up with the various geology surveys. Here we can see our team at the office, and we have 4 young enthusiastic geologists visiting us, and we are teamed up with them to design and experiment how we can store heat down in the hole, and what happens with this heat. If it can it be stored and extracted and used later on. So this is what we are looking for. This is one of our project meetings. Well, with this, I will say thank you from the Faroe Islands.
Thank you, Bjarne. Sort of caught me in the hop there. That's a very interesting discussion with Bjarne. He's dug a 400 meter deep hole for experimental heat storage. This is going to be interesting to see how that works out. I'm just going to move on now. Thanks, Bjarne. I'm just going to move on to another partner closer to home. This is Leo Strawbridge, who's the energy manager in Derry City and Strabane District Council, and we'll talk about retrofitting one of the council buildings with a wireless heat management system.
Okay, thanks, Nick, and thanks to my colleagues for their presentations earlier. Barty, could you stop sharing your screen so I could share mine, if you don't mind?
I think you can overrule them anyway.
Okay, I didn't know if I could or not. Okay. Yes, I can. Okay. So, can everyone see my presentation? Yes. Can you see it, Nick?
Yes, can see that, Leo.
Okay, thanks, Nick. Okay, so what I'm going to talk about is the intelligent energy management system that we installed in Harbour House, which is an old heritage building that well, not an old heritage building, but it's one of the heritage buildings that the council has. It's been around since the 19th century or so, and we were keen to sort of look at using a local company to do that could potentially save us a lot of energy. So after a bit of research, we found this company based in Northern Ireland, not too far away from ourselves, HeatBoss, and they were guaranteeing that we could reduce our energy consumption using some sort of innovative wireless technology by 30%. And their savings have already been verified by the University of Ulster University, as it's known now. So we needed a system that could work with radiators and with the BMS system, although the HeatBoss system does work with other forms of heat as well. In our particular case, we needed it for radiators and a BMS system.
Leo, sorry, your volume's sort of fading in and out. I don't know if you can get a wee bit closer or something.
Right. Can you hear me okay now?
Yeah, it's better. Yeah, thanks.
Okay. All right, now I'll hold the microphone a bit closer then. So so the Harbour House, as I said, is an heritage building built in the 19th century, and because of the quite large walls in it, it needed some sort of Wi-Fi enabled system to control the heating in it. So we had a number of Wi-Fi boosters installed in it, and each room we have a number of rooms that we control within the building was fitted with a thermostat and a controller on the actual radiators itself. So if we just go on, we can see there that that's a photograph of the radiator, and down on the right hand corner you can see the actual control valve that was installed, the wireless control valve, and each room also has that thermostat, which is also a booster control on it. So staff can control the heat in each room by either using a Wi-Fi enabled thermostat or via a heating schedule, which is set up through another active web-based app. I'll show you an example of that now. As well, outside the scheduled heating times, the thermostats can be used either to boost, so you can press the thermostat to boost the heat in the areas you can, and that was quite useful. If you look at our layout here, because each of the buildings, there's only one of the rooms that's actually occupied all the time, and that's the DS office there, and you can see that the temperature there is set around 21 degrees or so. It's slightly above there, 21.3. But the other rooms are used by our elected members, so they come in and out as need be. And that was one of the problems that we had, is that we didn't know when they were coming in, because they could come in at any time, and they weren't really telling us when they could come in or when they were coming in. So it meant that we had to keep the rooms at a high temperature for them. But as you can see here, we can reduce the temperature, and either if we know they're coming in, we can set the schedule for them, and if not, they can boost it when they come in. So just moving on, we can see that the other areas are kept at a lower temperature as well. So we have a boardroom, and we have the corridors, which we don't need the same level of comfort control as we do in the office or the offices that are used by the members. So the schedule identifies there that in the office that's used by the employees, that it's set to 21 degrees. And you can see there it's from about 8 in the morning to about 5 at night. Obviously, with a Monday, it has to come in earlier, because the building's not occupied on a Saturday or Sunday. The building does tend to cool down a little bit more over the weekends, so therefore we need to boost that a little bit more on Monday. It's up to an adequate temperature for employees. And then if you look at the other buildings or the other offices, you can see that we keep the temperature there about 19 degrees or so. So it means that if an elected member comes in to use that office, that it's not sitting at a lower temperature of about 14, 15 degrees or so, and takes a long time to heat up. So we found that if we keep it around 19 degrees, it's reasonable enough for people. And if they need an additional heating boost there, that can be done either by telling us in advance. So it's at the schedule, or
Leo, sorry, we're still having problems here.
Okay.
Maybe speak a wee bit louder or something. It seems to come and go, but if you could just maybe.
I'm not sure why that is the case.
That's great now. That's,
okay.
Maybe need to get the microphone closer.
So I've got the microphone right beside me now. That's what happened. Sorry about this. So what I was saying there was,
don't want anybody to miss anything.
No, so what I was saying there was that obviously in the elected members' rooms that we keep the temperature at 19 degrees, so that it doesn't necessarily mean that it has to be boosted by a lot when they come in to get it up to the comfort of 21 degrees for them. So then just moving on, you can see there that we have saved money over the period of time that we installed it. You can see that this shows it beforehand, and this installation was put in February 2021. And you can see that there was a marked increase or decrease in our costs there. I would say that some of these figures were taken over our lockdown period. The building isn't sort of completely operational again, so we have to sort of understand that these figures need to be verified over the next year or so when the building becomes a lot more operational. So it does. And then similarly from March or from February, March of 2021, you can see that our carbon reductions in the building have decreased as well. From a high there of just over 2.5 tons of CO2 equivalent. And then what was the challenge that we addressed in this project? Obviously the high cost of heating and the running costs, so we've reduced it by 30% by only heating the rooms that required and maintaining the temperature well within them. And then difficult to satisfy customers or occupants thermal comfort. We enable customers to customize comfort levels within the building with impact on the other. So if you set the temperature in one room, you're not keeping all the temperature, all the rooms at the same temperature to start with. So therefore, if someone comes in to boost it in one room, they're not impacting on the other rooms as well. So it is a simple, cost-effective, and non-destructive installation. It didn't take very long to install, typically about 2.5 days or so, and the typical payback. So it is easy to install, and then quick payback based on 30% savings. So that's everything. Thanks very much. Question? Ask them there. Thank you. Thanks, Nick. Sorry about the sound problems.
Oh, that's great, Leo. Thank you very much. Another interesting project, and it's good to see some figures on saving money. I'd like to move on now to our next partner, our Norwegian partner, Øystein Kleven, and he's a senior research scientist at the SINTEF Research Institute in Narvik, which I think is in the Arctic Circle. And I'll just hand you over to Øystein now. Thanks, Øystein.
Thanks. Because of the question, the Arctic Circle, I've actually put in an extra slide just to show where it is. So yeah, we had original pilot in the way north of our location. That was unfortunately not possible to continue with, so we ended up with doing off-grid households in the north, and we have another which is more on a company with a factory, a concrete factory. So I'm talking about the households in the north, mainly the challenge of going off-grid, and what we have done here. So first, a little bit about SINTEF. We are one of Europe's largest independent research organizations, above 2,000 employees, 75 nationalities, and a lot of customers with a lot of revenues and international collaboration. So the Arctic Circle, we are, can you see my mouse? Or
Yeah, we can, Austin.
Yeah, we can. Yeah.
so we are located here above the Arctic Circle, and the original pilot was in this region, so quite far north. So the pilot I'm talking about today is the off-grid households. We've started out with one pilot in Lofoten, which is the red dot furthest out, and this has been increasing number of households throughout the project, where because of interest has increased in Norway for going off-grid and renewables. And so we have ended up having 4 pilots and looking into more, or 4 cases in this pilot. So the background is there is an increased interest in renewable systems. Solar is increasing on a global market, especially in the rural areas. There could be really high grid connection fees. So one of the pilots we were talking about, or case we were talking to, had a connection fee estimated between 50 and 75,000 euros just to be grid connected. And also when you get out in the rural areas, there are more problems with the grid because of weaker grids and sensitive to weather, if it's storms and that goes down. And also there is an interest of being independent and have self-consumption. So pretty much determine the price structure of your electricity and heating demands in the future. So we started with 1, and now there is 4. We are looking at more renewable systems that will be added on in a later stage, and has a large range from people that we approach, which had an idea of going off grid and looking into the challenges to that, to a system that has been operating since 2015. So this is the system that's been working for the longest, one of the few cases I know of in Norway. It's completely designed from the bottom up, with a lot of features which makes them quite self-sufficient. So they are fully supplied by electricity, heating, their own water with a well, and a waste management system to handle all the water and waste that comes from the household. It's only 2 people living here, and they have been living here now for 6 years, 6 winters, which is the most challenging part. So what we have been trying here is how to improve their living standards and give recommendations for improvements. As you see here, the yearly average production is only 1500 kilowatts, and that's about 75% of solar and 25% of wind, which is quite low compared to a grid connected system, but it's a closed loop where you have to utilize all the produced energy, and this is behind the inverters, so behind the batteries. So we are actually not getting the full picture of the production side, which is one of the key things we have discovered, is that data for these kind of systems is really difficult to get. So in the winter time, of course, above the Arctic Circle, we don't really have sunlight. So nearly 0 kilowatt hours from the solar cells. So the first winter, they actually had to go out in the local river to clean their or wash their clothes. So that's not really something all people want to do. It's not acceptable for everybody to do that. The other system we've been looking into is actually 2018, sorry. They built a new house as well in 2018, late 2018. They started off-grid, but realized that there is a challenge, especially with small children in the family. It's more challenging to sustain the life quality they wanted. So they actually had to borrow for a time the electricity from neighbors. So they had a small wire going across. So this was nearly off-grid. So at the moment, they are still discussing if they are to be grid connected or not, and if they, if they need to increase the production side. So the design considerations, the challenges is mainly the winter months. There is little to no solar energy. So there is a need for an alternative energy source or other production. Most of the people we've talked about or to has not wanted to go into making a simple diesel generator or a petrol generator to cover the worst parts. Since these are household families, it's the running cost and installation cost is of course really important to them. You can cover quite a lot with battery technology and solar and wind and others, but it becomes expensive if you need to cover a normal way of life. So in Norway is a problem that if you're nearly off-grid, it's the same cost as if you are on a standard grid connection. And of course, for them, the complexity and uptime plays a role. They need to be able to live even though there is challenges in the wintertime. So as I mentioned, our problem was there is very little data on the production side. Most of these systems are not monitored. And people are at the moment not sharing their experience as much as they should. So this is where we also have tried to be a bridge between the different cases. So we have been looking at mainly solar and wind. Biomass is mainly wood, has been used for cooking and heating for most of the cases. That's the simple and readily available energy source. All of these cases has been using water accumulation tanks for especially hot water. Battery packs is of course an expensive part, but it's really necessary to be able to spread out the local energy production. And stocking up on wood would of course mean that you have an energy storage in the area. On the energy usage, we've seen and recommended a lot regarding minimizing the the uses, of course, looking at the highly efficient products like washing machines, looking at preheating, using the preheated water rather than cold water in the washing cycles, for example, and being selective at what time you are actually producing this, and yeah, selecting good low energy products when choosing. So paying a little bit more on the purchasing side often pays out in the end on these extreme cases. So what we have done is going into the production side of the different energy sources, mainly solar and wind, looking at where is the potential losses and improvements, then looking into what kind of steps could be made in terms of getting that increased energy security during the winter time, which kind of add-on systems or solutions can be made there. For tackling this data issue, we have been looking at or developed autonomous system that is ultra low powered, that can be placed into the field, that doesn't depend on existing structure or access to power, and it has a low material cost. So at the moment, we are mainly having sensor for temperature, heat, no temperature, solar and wind, but looking into expanding that as well. So that was all from me.
Thank you, Iceland. Thanks very much. And it was very interesting to hear the particular harsh challenges of trying to be off-grid above the Arctic Circle. So we'll move on to the last speaker, which is me. So I'm just going to share my presentation here. If you just bear with me. Okay, hopefully you can all see that. So this is the pilot from Letterkenny Institute of Technology, and I suppose like everybody, we went through a few different pilot options before we looked at this particular opportunity, because we had the space to do it, and it was to look at electric vehicle solar charging pilot. Just to give some background, first of all, our institute here has 2,800 students and staff per day, about 766 car parking spaces, full most days during term time. That we need additional off-campus parking. We are currently building an extension of the car park, and it is at that extension that we are developing our pilot. So our current facilities are there. As you can see in the picture, we have facilities to charge 2 electric vehicles. So our thoughts were around, what about, can we have renewable energy to support car charging? We know with it's not just about putting electric vehicles on the road. If your electric vehicles are using batteries charged with fossil fuels, it's not a great solution either. So we must look at the renewable energy. So just briefly, in Ireland's status, we're looking for emission reductions in electricity of 62 to 81% and 42 to 50% in transport by 2030. We're looking to reduce transport emissions to reach 1 million electric vehicles per day by 2030, and looking at public bus electrification and increasing proportion of our renewable energy to at least 70%. Our electric vehicle uptake, looking for 1 million electric vehicles on the road. But currently, according to the SEAI, we only have 41,000 EVs on the road, and that includes plug-in hybrids. And there in bold, you can see that for the first 6 months of 2021, there's green shoots of electric car sales. 36% of new car sales were diesel, 32% petrol, 18% hybrid, 13% electric and plug-in hybrid. So 178% jump on the same period. There are grants, but the national charging network is still a long way off. Rough total of 1,800 generally available charging points, plus a smattering of privately held ones, so roughly about 2,000 individual points, and that was from August 2021. Solar PV in Ireland has had a low starting point. Really, wind has been our main renewable energy investment up to the recent times. So it's only started in the last 5 years. So we have small scale installations have been supported by the Energy Agency's domestic PV grants since 2018. Larger scale PV projects supported under Renewable Energy Support Scheme. And there were a total in August 2020, a total of 63 solar projects totaling 796 megawatts. What is the potential of solar PV in Ireland? Well, you know, there's a graph. We have good peak there period from spring to late summer, as you can see. You can see the picture of Ireland there, where we are in the northwest. Yeah, particularly cloudy. We are one of the cloudiest areas, I think, but still, you know, if Norway can use solar panels, so can we. So it's a seasonal thing, and it's a renewable mix is really what the solution is all about, and not depending, being trapped into one renewable source. So we thought about this, and we decided that for our pilot, we would experiment with installing some solar panels to charge a couple of slow chargers in our car park. We had the space, and we'll show you that later, to fence off some solar panels. And we also wanted to use some battery storage and really run that as a pilot and monitor it and bring all the data over from the car park into the building. We're going to display it on a dashboard, but more importantly, see how it works. So we'll have our battery storage here. We'll have a charging station with two plugs for 2 cars. And of course, we'll have the electric grid backup. We couldn't run it completely on its own throughout the year. So it really is experimental to see how this works. And so basically our installation will be a 16-watt peak PV array, and we're including some bifacial panels there, really, and that's just for experimental research to see how well they would work. Bifacial panel, that means you have a solar surface on either side of the panel, so it'll allow the backside to pick up reflections. A 10 kilowatt inverter, which will be a hybrid to allow battery charging. A 15 kilowatt battery, and a 7 kilowatt slow dual charger. So we're looking at all day partners in effect. And really the remit was to address the fuel poverty and insecurity in the MPA region and the over-reliance on fossil fuels. And that really takes into consideration, and it's been put into stark focus in recent times with the huge increases in fuel, diesel and petrol, and making this sort of solution something that we should look at quite seriously. So we wanted to incorporate renewable solar energy and battery storage to power these electric vehicle charge points with the backup grid supply. And we'll monitor this pilot, its feasibility in terms of efficiency, cost benefit performance, energy saving, the usage, you know, how often it's used, weather conditions, and from that then we hope to make recommendations. With this project, we will continue the promotion of renewable energy. The LYT here is particularly strong in promoting, and we have annual green days, and our states here are very good about promoting green aspects and green habits and good habits. We hope to get a dashboard on display in the main building, which will show the monitored outputs from the system. We'll have a 4G or a Wi-Fi connection from that. So this installation will suit slow charging. It'll suit the all-day partner really in both urban and rural areas. People who come into our institute will park all day, and really in a lot of EV use cases in both urban and rural areas, people really do mainly short journeys. And I know there is a thing about range anxiety, but the majority of our journeys are quite short. And probably the future of urban car charging network probably lies in a lot of street parking and public car parking spaces with flow chargers in them. So when people move in short trips around their area, they'll park, plug in, top up, move on. Don't really see that there be it's for longer journeys and the motorways and the main routes that where you would really need the fast chargers. So a pilot like this, I think, could be rolled out if successful, and if we see some benefit, it really could be rolled out in sort of remote rural settings, small clusters of houses, small communities who could set up a community PV storage charging stations along these lines. But it'll be interesting to see how the results turn out. Well, implementation, we've had some delays. Like a lot of people working in the last year or so, with delays with COVID. We actually had to get planning permission, and we had a challenge, unbelievably, to the planning permission. You can see there, for people who know the college, this is the planning permission on the right-hand side. This is the planning permission documents that were sent in. Shows the plan of the area. So this is across the road from our main building. So this is our car park. All this is green space, is sort of waste ground. The blue dotted line here shows where our car park extension is going. And if you look behind Ben's the lead technical engineer on this project. And we were over yesterday looking at progress in a very bleak, cloudy, non-solar day. So just beyond, you'll see behind that fence is the extended car park, and then just beyond that, where you'll see just the waste ground, that's where our pilot's going to be. So you can see it's obviously not built yet, and you can see the plan there will have two rows of double height solar panels, and the two chargers will be there in a bay of the car park right at the back. So we have had some delays with tender implementation and sorting out the pilot at the very, very beginning, but we have finalized the tender, made the award, and we're hoping to get the installation completed by the end of January. So that will just be squeezed in before the end of the project in March. But as has been mentioned, the project will have another vehicle to promote its results through the HITER project, which is another MPA cluster project, bringing together several MPA energy projects together with a concentration and dissemination. So that is that's the plan there. So that brings me to the end of my presentation. I will just stop sharing here if I can. And just maybe we should have we got some questions, so we'd like to have a little bit of a Q&A session here. We're not too bad for time. I think we're scheduled to go on for 2, but we'll see how we get on. Not keep you too long, but I'd like to work through some of these questions. I see a few more have come up there. I'm just going to start with the ones that came in at the start. And one came in for, are all the panelists still there? I think everybody's still there. So this one's for PEADAR, came in from our colleague Ragnar, and he wants to know what is the work medium in the heat pumps, brackets F gases.
I'd have to check that out for Ragnar.
Yeah,
and I can come back.
A friendly question from one of our partners. Yeah.
Aye, fair play to him.
Okay, well, listen, you can work away at that, and I'll. Oh no, there's another question for you. This is for Keir McGrath. Is the PV all used within the building, and is there any exportable renewable electricity?
Yeah, no, there's nothing exported. It's all used within the building. And there was another question there in relation to radiators, I think.
Yeah.
So all our existing radiators were used. They were inspected prior to the design brief, and all fit for purpose. But we also added in on that project, we also added in radiator circuit to our council chamber within that building that was previously being used by heated by an air handling unit, inefficient. So as part of the project, we put in a new zone to our chamber and have 5 new radiators installed. But for the rest of the building, it's all the existing radiators, and we have part of our foyer was on the floor. So no changes to the existing radiators.
That's great, Peadar. Thank you. I have another question here for Kieran, from Kieran McGrath. Was there a particular reason why air source was chosen, air source and ground source chosen across the projects? I think that's right. Let me just check it there. I think he's talking about was there a particular reason for some partners selecting ground source heat pumps and others selecting air source heat pumps? Well, I'll just take a wee bit of this and then I'll pass it over to maybe Bjarti and Peadar. One of the objectives was to run as many was to get a renewable mix as much as possible to show how for a stable renewable energy supply you couldn't rely on one renewable energy source. There was no on the partners, we didn't say or didn't give them any restrictions into what renewable energy sources they were going to use, and obviously they were also going to work within their policies. For example, district heating in Finland is quite widespread, whereas for ourselves here it's rarely used and hasn't really been considered until recent times. You know, so one of the benefits of this project was to transfer this knowledge and this learning between the different partner areas and different countries, and to use as many different renewable sources as possible. Now, on the particular reason why Bjarti went with ground source and Peadar went with air source, I'll maybe if you guys would like to jump in there.
Well, for us in particular with Milford, it was again kind of tying in with the logistics and what we were working with in terms of the building itself. So the oil tank was beside the boiler house. It was only 3 meters from the boiler house, and the fact that when we sized up the air source heat pumps, the fact that we could get the 3 inside that existing bund, so we'd only a 3 meter travel distance, you know, to get into the control rooms and into the pumps. So for us, where that actual bond was, and for able to use that, we wouldn't, if you've seen from the lorry removing the oil tank, we actually wouldn't have got in the same equipment you've seen there that Bjarti had. We actually didn't have those location spaces to get that type of equipment in to even put in a borehole. So for us, it was more about the logistics, and it did tie in with the costs as well.
Thanks, Peadar. Bjarti, do you have anything to add there?
Yes, since we started to use heat pumps in the Faroe Islands, and that is not that far back, it's 10, 15 years since the rollout of heat pumps general. The first heat pump from 2007-8, they were mainly, for now I'm talking about private houses, they were mainly air to water heat pumps, and some of them are running still, but we have some not that good operation. We do have a very harsh environment with salty air around, so some of the air source heat pumps, the equipment outside the house has not a long living time, only for 10-12 years, then you start to get difficulties. even if ground source heat pumps, it's a much more expensive system. The majority now goes for ground source heat pump, and especially when it's big systems, it's mainly ground source heat pumps. And in the long, because they are more efficient in the air to water heat pumps, you need to thaw the frozen thing that comes on. So the efficiency of ground source heat pump is much higher, and then on the longer run, it becomes a cheaper system.
Thanks for that, Bjarne. Hopefully that answers Kieran's question. Just want to look here. There's a question here for SANNA from Fabian. He asked, the water storage tank, when will it be charged? Or I think what he means is, how long will it take to charge it? Is it just over a few days or hours? I don't know, SANNA, if you could. It's a pretty large tank.
Hi, can you hear me?
Yes.
Yeah, I've had so much misfortune with my microphones that I'm always nervous when talking. I have to get back on you on that, because there's been a bit change in the design lately, and I don't want to say anything because it will be I might be lying horribly, but I'll check it up and get back on that. Okay.
Thanks, Sanna. Okay, no, sorry, I was just looking down the questions here. There's been some questions asked and answered in the chat. I think everybody should have access to that. There was a question here about oil companies in Norway. I think, Oystein, you've been dealing with that one. There's a question here about the solar PV and storage from Ryan. Will the 7 kilowatt charge points dynamically adjust output based on available solar energy, and will battery be charged from the grid during the winter months? Would be interesting if real-time grid CO2 intensity could be investigated and potential impact or solution. Well, we're not charging the battery from the grid. The battery is only to be charged from the solar. We know the battery is quite small, really, from what we're doing, but we were limited by budget. Pilots for this project are quite small. So we're really going into the dark a little bit. We put as much money as we could for it into the system, and we're really looking to see how it works for us and what the performance is like. And you think you make a comment there. Would be interesting if real-time grid CO2 intensity could be investigated and potential impact or solution. Well, we'll definitely consider that. Oh yeah, there was a question as well, came in right at the very start to Ziggy, how much wattage for each of the turbines in Iceland. And although Ziggy wasn't live with us, his colleague is Ragnar is in the audience, and he's let us know that they have 2 6 kilowatt turbines at the moment. They're hoping to increase that to 4. And I think they're going to even potentially put in a bigger one to try and completely get rid of the diesel. Okay, I don't see any more questions there. I'm just looking at the time, it's 1:45. I think I just would like to, I suppose, sign off now. First thing I'd like to do, I'd like to thank all the partners for coming today and giving us some very interesting presentations. I'd like to thank them too for sticking with the project through a very difficult couple of years. We had delays. We had to get an extension to the project. We got 6 months, and there were a lot of delays, a lot of difficulties for everybody. We stopped meeting. Everything had to go online. Of course, I'm just echoing what's happened all over the place. So it's been difficult for lots of people. All of us but so I just want to thank these guys in particular for sticking with the project, and we kept the meetings going, and hopefully we'll have a real live event in Finland in March, in the end of March. Hopefully the Omicron will not be as bad as it seems to be. Hopefully it'll be okay. I'd also like to thank our audience today. I'm really quite impressed that the numbers hung around. Normally they tail off, but they actually they hovered around there, Maria, and didn't tail off at all. So I really would like to thank everybody who turned up, because I certainly know that we are all suffering a little bit from webinar fatigue at the moment, you know, and we all sign up for lots of stuff and then don't join. So I really appreciate that, and it means a lot to all the partners. There was just one question there. It just occurs to me. I think might have been I meant to get to it, but oh yeah, it was from Kieran. How are all the learnings from each of the partner projects shared for maximum benefit to the MPA region? For example, pilot crossover experience between partners. Well, we share everything between ourselves. We have regular meetings, and for example, Iceland, who's an expert in solar panels, has been basically giving us the benefit of our advice, and he's guided the writing of our tender and the technology we select, and to try and get the leading technology. But also, it's running events like this is where we share with all our colleagues in different countries, and it's been more difficult doing it online, but in some ways you can reach more people when you do it online. So it's really all about dissemination of the information, and we hope to, you know, on our final conference we'll have many more results, I think, much in terms of outputs, and then going on forward with the heater project, which we're part of, that will extend on into the summer, will give us another platform to put out results. So I think that's all for me. I'd just like to thank you all, and listen, enjoy the rest of the day, and all the best from us here in the SMARTrenew project. Sorry, Maria, I forgot to remind you about the yeah, so those are all our contact details. If you want to get any more information on this, you can get onto our website, smartrenew.interreg-mpa.eu. We are very active, thanks to Maria, in social media and Twitter, Facebook, and LinkedIn. So leaving that screen up there, I would like to say bye to everybody, and we'll see you again soon. Thanks now. Bye.
Okay, bye.